Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. If you haven't heard about the Data Unchained podcast before, maybe this is your first time listening, let me tell you a little bit about the show. In the last several decades, the data access methods and data location methods have changed dramatically. We've had the advent of cloud computing and cloud storage. We've looked at data being generated increasingly at the edge and by sensors all around the world. And Data Unchained focuses on the technologies available to help you get access to that data and put it to work in the applications and user environments where it's most valuable. We'll be delving today both into the problems as well as some of the solutions out there to help you make your data most valuable as a global resource. So let me welcome our guest. Many of you may know him already. He's a longtime colleague and friend of mine, Jacob Farmer. He's the chief product evangelist at Starfish. But Jacob, you definitely have a lot of experience beyond being a chief evangelist, I would say. Maybe you could tell us a little bit about yourself and the founding of Starfish.
Yeah, sure thing, Molly. So I been in the storage industry since before there was a storage industry. I started in 1990-ish. And at the time, I had this a business mentor. I actually think this guy might be in jail right now, but that's incidental. And he gave me this wonderfully sage advice. He said, if you want to start a business, you want to pick a niche, something that no one else likes to do, and make it your thing. Like, get really good at it, be conversant, have all the right tools. And the analogy that he gave me were the guys who clean up crime scenes and sewage spills, right? No matter how bad the economy, you don't want to clean up your own sewage spill. What's the analogy of crime scenes and sewage spills in the data center? At the time, it was the backup system. I think it might still be the backup system. But I decided that I was going to become an industry expert in backup systems. We built a company that sold hardware, software, tape media, and we were agnostic to whatever vendors you like to use. We would just help you design and implement your backup system, and that's how I got into this thing. And then, of course, the storage industry began to emerge. We had SANSs and NASs and HPC file systems and clouds and all this other technology. So what happened to me was that I was like this vendor independent storage expert when there were no storage experts. And then I got drafted by all the startup companies to, be their little darling and take their products to market. And from there, I just developed a really large client base, a big feedback loop of people who consume storage and people who create storage solutions. And that's been my shtick ever since. It's just to kind of be like an interluminary in the storage industry.
Tell us a little bit about Starfish. It goes beyond storage, I would say, in a lot of different ways. Maybe you can talk about the problems that you felt were maybe a gap in the industry and a little bit about what the Starfish technology does.
Yeah, it's kind of funny when I try to unwind how we got here. It was actually through many different ideas and threads that converged on, oh, gee, wait, all of these things are the same problem. So I'll tell you a little bit more about my creation myth. So the other sage advice I got from this guy who I think is now in jail was that the way that you build your expertise is to proclaim it. So he said you just sign up to give a talk at a conference, and the first couple times you do it, you'll be an imbecile spouting nonsense. But there'll be some ranters in the audience who come up to you afterwards and they want to school you on everything you said wrong. Well, if you take good notes, you get a good lecture from those guys. The next time you get up and speak, you'll be a little less wrong. And then by the third or fourth time, you'll actually have something interesting to say that attracts people to you as an expert. I know this all sounds kind of kooky, but this is how I, as like a 25-year-old, proclaim myself a storage expert. And, after a while, you fake it till you make it. So here we are. In any case, I got involved in organizations like the Usenix Association and the Storage Networking Industry Association, where there were actually some really sophisticated end users there. And they would all want to show off like the software that they built because their needs are so unique and because commercial products couldn't possibly address their scale or the nuances of their particular use cases. And then they'd show me this unique software they had to build, and it would be exactly the same as the unique software that the last guy had to show me and the guy before that. And what I realized was that there's kind of like this set of common denominators, that prevail among all people who manage big file systems. Like there's just stuff you want to be able to do and ways that you go about doing it. And indeed, these people all did go and write their own. But that led me to believe that there is an opportunity to build some common tools that manage all things unstructured data. So that's how I got here. And then really what it was is there were so many different problems that amounted to the same. Like in backup systems, the big problem that we would have was how do you back up a giant NAS? And what do you do if there's billions of small files and really deep directory trees? Like, those become metadata choke points and systems don't work. And what about archiving? Like, how do you move some files from one storage device to another and then bring them back again or go consume them from where they're located? And these sound like simple problems, but when you deal in big, complicated file systems and you deal with the actual nuances of how different companies work or how different users within those companies work, you realize that there isn't one size that fits all. Like, so when somebody asks me, like, how does Starfish do archiving? I don't go, oh, well, you hit this archive button. I go, well, how would you like it to do archiving? Like, how does archiving work for you? And okay, let's mimic your workflow rather than having you adapt to the one that I arbitrarily picked on your behalf. So in any case, that's kind of where the ideas all came from, this client base, and then we built the product in a feedback loop with, power users, like organizations with billions of files and some of the biggest file systems in the world, and and here we are.
So I think it's interesting in today's world. Everyone's talking about data. AI has caused a bit of a frenzy on the data front, but there's been other data analytics initiatives going on for the last several years. And in our industry, we've talked about, wow, unstructured data grows so fast and there's so much more of it than structured data out there. The world is comprised of unstructured data. And as you think about these data initiatives going on today, where does unstructured data play in it? I think we've talked mostly about how to store and archive it, but now people want to use it. How are you helping overcome that challenge?
Well, this is a tricky one because everyone's chasing their tails. There are obviously a handful of users who've really figured out how to use AI to achieve things. There's a useful distinction I would make between what you and I call unstructured data and what somebody doing AI considers unstructured data. So we think of unstructured data as the files, data that isn't in some kind of schema or tabular format. It's just files thrown around everywhere, and you what are they? You got to make sense of them somehow. And I think to someone doing AI, a unit of unstructured data could be like a video file. Like the inside that file is data. So there's two problems. One is like finding or getting to the files that you want to analyze, and then the other one is actually looking inside them and analyzing them. So Starfish is kind of the corraller. It's like, what do I have and where do I have it and how do I access it? And that should be, you might think that should be an easy problem, do a find statement and there's the file, or, open up the browser and click. But of course, if you have thousands of data volumes, or if you have massive file systems with billions of files, and files have been generated all over the place for many, many years, how do you discover what you have and what to feed to your training models or what you want to analyze? And I think this is the uncharted territory. Like most people think of this as untenable or something that they have to kind of slog through eventually. And of course, my mission is to let them know that we have tools for doing this. It's not impossible.
And I think your point of, taking a find statement or something that may be just in a developer's toolkit is a solution. But when you start to think about data sets in allotted locations, that gets harder and harder to connect to the different data environments and know what's in different silos, access it. So it seems like the problem is larger when you have multiple data sets or distributed data sets.
Yeah, so there's a fundamental problem, which it's one of those things that doesn't really occur to most people, but big industrial file systems tend to be based on POSIX. You access them through NFS or typically NFS, and POSIX is really limited in the way it does permissions. Right, so you're either root and you can do everything and anything and create havoc, or you're not, in which case you can only access files that you have access to. There's no notion of accessing somebody else's files for some administrative purpose. Now that exists in the Windows world, but it took a long time to get there, and it doesn't exist in the Unix world or the POSIX world. So so one simple problem is, like, how do we go and mine files that aren't ours? And the answer is, well, the storage administrator or the Unix system administrator would have to do that, right? And that's not that typically that person's job. Like, the person who manages storage backs it up and migrates it and adds more capacity. They don't mine it.
And I think that jumps into a really interesting question. We chatted a little bit about this before the call, but so is Starfish and Hammerspace, and from your perspective, are we competitors in what we do in kind of helping to solve this problem? So is there a partner place in the middle?
We're competitors for Google searches because we use common verbiage. Like, I don't know. Let me turn a question around and ask you, like, what are some keywords? Like, if you what do you buy AdWords on? When you're for searching.
Yeah, definitely. I mean, there's the obvious storage terms that everyone grabs and then tries to convert, a NAS sale into what we do. But the big ones are all around data pipelines, decentralized data, data orchestration, moving data around.
Yeah, so orchestration, and then I think, like, if somebody were to say, gee, what labels would you use around Hammerspace's core IP? And you might say, well, we have a really novel way of doing metadata. Like, I think that's a safe thing to say about Hammerspace. And Starfish is a novel way of doing things around metadata. And they start sounding like, oh, well, you guys are doing similar things, but really not. I mean, metadata just means the data that describes other data. And in a unstructured content stack, there's all kinds of metadata. There's the metadata from the storage system. That's the stuff where you guys do some real interesting magic. And then there's metadata that's like organizational, that might belong to some user process, or there's technical metadata, like what are the specifications of the file, and then there's the content of the file, or there's all kinds of metadata. And then the question is, what do you need it for and why? Like, what problem are you trying to solve? So I kind of see it like no, we're not. We're competitors to the degree that there's some overlaps. I mean, I think Hammerspace abstracts the physical location of a file in a way that's pretty seamless and cool. And Starfish is like, well, if you don't have that capability, then you would need to do it in this other way. And so arguably, if you bought Hammerspace, you wouldn't need Starfish for that use case. But then there might be 1,000 others where you need us. So I'd say in the Venn diagram, there's a very tiny overlap between you and me.
Absolutely. And I think a good way to make that more real is talking about maybe your optimal use case. And I'm happy to talk about Hammerspaces as well. Like, so what do you think? What is your perfect marketing terms, ideal customer profile? Or
this is a sad topic for me. You've asked the most painful question for me, Molly, which is that, all right, so when I dreamt this thing up, so I didn't really tell you what Starfish is. I'll do a really quick one. We're a data catalog, a way of enumerating and discovering the contents of your file systems with the ability to automate based on whatever's in the metadata or whatever's in that catalog. And the goal I had when I launched the product was I was really hoping to begin kind of like a lightweight curational process as files are being created, and as they're working through their workflow, so that, if you're doing science or some other type of R&D, by the time you've kind of come to the end of your experiments, you're already like curated your data and you're ready to organize it and publish it, right? Rather than trying to figure out what is all this crap and making sense out of it later. And then the goal was, I wanted to enable science.
Which never happens, incidentally.
Yeah, right. It never happens, right? Now, in science, they're trying to make it happen. There's all these new mandates that make grant-funded researchers submit their data to various repositories or to make it shareable and accessible. But it's an enormous pain in the butt for everybody. It's not well-funded, and it sucks. But, my hope was that I'd be able to preserve and reuse, data that enables science and, preserves our cultural heritage. Now, the sad reality is that my number one use case, sorry for the long answer, is delete. Like, people want to get rid of stuff. And the question is, what can I delete? And turns out it's a hard question, because who knows the answer to it? It might be in the file parameters. That's easy to query for, but it might be in the content of the file. You got to open it up and extract clues and deduce something. Or it might be in the heads of your users, in which case we need an interface from them where they can identify which files they can delete. So I'd say delete, and maybe as a superset of delete is rot cleanup, where rot is the redundant, obsolete, and trivial data. But either way, like figuring out what the crap is and getting rid of it, taking out the garbage. That's the big one.
I've never heard that acronym. I always think of bit rot when I hear the word
Yeah,
rot
right.
in the world.
I don't know where I got that. I didn't make it up. I wish I had. So what about you? What's your killer use case? The thing that no one else can do?
Yeah, definitely. And it definitely sounds quite different when you think about it from a technology, but also use case. Ours is all about delivering high performance to data anywhere. So you have a remote AI engine, maybe a remote user, a remote render farm, and you want to have high performance data access from data that's decentralized from that data. So my data sits in 4 data centers, and I want a really, really fast data pipeline into a GPU farm in Azure in Canada. And that orchestration of high performance data is really what Hammerspace does. And I mean, I think the synergy to you and I, because we've talked about and thought about this a lot, is obvious that which data do I have and which needs to be orchestrated and moved very, very quickly is where I think there's a lot of overlap in our technologies of we have the technology to place data where it needs to be done and kind of overcome the whole concept of data gravity, but you have to know which data it is you want to move. And that's where I see a lot of synergies between the two companies.
Yeah, and I'd say it even just a little bit differently, which is that I'd say like you have a file system with a magic trick. Your magic trick being that you're able to present the same namespace across geographies in a consistent way with high performance read and write access. Like that's pretty magical. But almost anyone who's likely to have a file system like that is doing something interesting with those files. Like the files probably are valuable and essential to their business, and they probably have other unsolved problems. Or they have other storage devices, and they need to federate those storage devices maybe in a less seamless way than the way that you would do it, like because they've got a disparate system. It's not connected in any meaningful way. So I see Starfish really as just being the enabler for that thing you wish you could do that would make your workflow work properly. And I think what's cool, like we all, I don't know, we all think about what does our users really want. Every user wants, or everyone wants for their users, transparent access to data. The data is always stored in the right place, the right time, the right performance, the right cost, but the users don't have to worry about it. But that's a really elusive goal. Like I kind of kid, like, I want a pink pony. You don't see me getting one of those anytime soon, right? But if you're able to deliver some portion of that, right, and that's awesome, and it wins business for you. I do it the other way around. I say, I can't give you that. I can't make it seamless, but I can manage those seams really thoughtfully and practically. So really, it's kind of like wherever there are gaps, there's a use case for Starfish, and wherever there's a really cool product like yours, now there's another interesting set of challenges we could tackle.
And to me, I love that concept of what do people want, and we've been trying to solve it for as long as you and I have known each other. And I think we've figured out we've known each other for about 20 years, and
yes,
been in the industry even longer. And the advent of tiering and HSM and hybrid cloud have all been people trying to solve this problem, right? I want my data.
No, I would argue not. I'd say it's people trying to keep us from solving that problem.
Well, it's the tools that they've had available to meet their needs, right? I'm going to put my archive in this spot, my performance in this spot,
okay,
but it's not unified, right? They keep getting new technologies that aren't tied together in any way. And that's how they've solved their performance needs and their capacity needs. But it's not elegant. It's not automated. It's not simple.
Well, right. So the problem, again, coming back to the fundamentals of how storage works, the APIs for file-based storage are things like POSIX and NFS and SMB, and these are not very rich APIs. They're wonderful for what they do, allowing you to access the bits on a shared storage device, but they're not tools for management. And the vendors who make big storage devices, they tend not to create open APIs to facilitate their competitors pulling data out of their ecosystems and into the competitor's ecosystem. So the siloing is by design. It's how life works. So if you want to break out of the silo, you have to insert yourself somewhere. Now, I feel like what Hammerspace did that was super clever was you found a really interesting insertion point. Like your essential magic is living in the client software on the host operating system, right? That's a very unusual place to sit. And it allows you to create a federated a namespace that federates disparate storage devices together. Now, there are other constraints that you have to work around, and there's places where you can and can't play, but it's a really cool way of doing it. In the Starfish world, I had to work with much more constraints. I basically had to say, all right, there's no official way to do this. So how do people improvise? And the way that we improvise is we build a global catalog. So your metadata is file system metadata that you found an interesting way to make it usable. Like mine is application metadata that mimics the file system. So I'm actually synchronizing the contents of the file systems into my metadata and then doing my tricks from there. But I have a huge hurdle, which is I got to synchronize the metadata first. And this has actually been, for me, or for Starfish, this is where we've differentiated across the rest of the industry. Like everybody has this problem. Like if you're backup software, you got to inventory the files to back them up. And if you're archive software, same thing. And if you're reporting software or governance software, same thing. You got to somehow or other read the contents of the file system and synchronize it with your own catalog. And all we did at Starfish, I shouldn't say all, it was a huge effort, is we built our catalog to be massively scalable and flexible so that I can work in the world's largest supercomputing environments, for instance, and to handle like just this crazy diversity of things that are out there. But that's like it's sort of two different ways of life. Like you came up with a really novel way to use file system metadata in a file system, and I have to synchronize it to my system to use it.
I was kind of thinking about when we position and talk about supercomputing or any of these really at scale environments, there's a variety of ways people think about scale. There's the number of files, there's the throughput, IOPS types of performance, there's the absolute capacity, and those all require potentially different ways of thinking about your architecture. And I think that kind of flows into an interesting conversation about in-band and out-of-band technologies. I think that maybe that's an insider term or not, but it's an important distinction of what's happening in-band versus out-of-band. And as you reach scale, which matters? Maybe can you give me?
This is a fun topic because it's easy to lose people on this one, but it's really kind of like you've got a host and you got a storage device, and they're talking to each other, and now you want to do some abstraction. You want the file to be somewhere else. So how do you put a file somewhere else and have it be discoverable to your user, right? So one way to do that would be to put some kind of stub or symlink on the file system and redirect the I/O, basically bounce it. And those, to me, those are like, I don't know, those are seams and they break. I think in your model, like you've got a novel way of being both in-band and out-of-band. Like your in-band on, well, all right, let me say it this way. Normally when you talk about in-band versus out-of-band, the metadata is on one path and the data is on another path. Like that's the traditional notion. But then you can also have the metadata be out of the data path or in the data path. So what's I think is clever about Hammerspace is that your metadata is in band because you're living in the client, or you'll insert a proxy into the data path, right? But you're the most part, the data is directly in band. I said that weird. Sorry. Your metadata is
you're going the right direction though. For sure.
it's messy because the metadata is out of band relative to the data. But
exactly.
It's in band for the regular metadata path.
The workflow. Mm-hmm.
Right?
Exactly.
So in my world, like the listing of the files, where's my file, is answered in an external application. And that's wonderful if you're automating or if you can tolerate a little bit of a bump in the wire. Like if your user's like, oh yeah, my file isn't where I want, but it's over there instead, and I can make an API call or I can get it, or it's not a big deal. But otherwise it's a rabbit hole.
It is. And I think for customers who are looking at their solutions, what they want, at least, is they want to use data that already exists. They want to know where it is and be able to move it. And there's different ways of accomplishing that, but it's all about getting metadata about the data exists and then being able to action on it, I think and there's different tools to it. But I think a big difference with Hammerspace is we move everything into our file system, even if it's sitting on top of storage that exists. And we offer that, like you say, the data path is extremely fast because metadata updates are out of band, but all of the metadata at that point sits in Hammerspace, where you can kind of tease it outside of the storage system as its own external catalog. Do you think that's a reasonable way to talk about it?
Yeah, again, the problem is we are still sort of comparing apples and oranges. So I would say, like, let's say a common solution we might both tackle. Our user has, let's keep it simple, they have two storage devices. They have a high performance file system and they have an archival file system. And they would like a relationship between those two devices. So you can do something really magical, which is you can make them look like a single logical POSIX volume, something we used to call the global namespace. And whether that global means it's across geographies or in a single geography is actually incidental. You're just making two storage systems look like one. And that's awesome. And I can't do that, right? I can represent them as a common namespace in an application, and my application has all kinds of API calls. So I may be able to preclude the need for your model of doing it, but the user is always going to prefer your model instead because your model is seamless. Now, there are probably some good reasons why the entire world hasn't thrown out their storage or subsumed their storage into Hammerspace. You got to break your way into the market. You've got to get over the cultural barriers and vendor relationship barriers. You've got to sell this thing, prove that it works, figure out where it works great, where it doesn't work so well. But I think if a few years from now, it's easy to imagine that everybody would want to have a file system like a Hammerspace to federate as many of their disparate things together as possible and make them look like one. Now, in my world, there's still, do you need a catalog of your files, and do you need a deeper understanding of what they are? And is there anything else that you want to do with them? And maybe you'd want to move some of those files out into an entirely different subsystem. Or maybe there's files from another ecosystem that you want to move in and out of the Hammerspace ecosystem. So then I become like a tiering or data movement solution where you don't have a seamlessly federated file system.
Do you find, Jacob, that this world of AI that everyone is talking about is changing the way your technology is being used? Is it just another use case and expanding on kind of HPC in general? How do you think about AI?
The problem with AI is the same problems we have with anything we want to do with our files. Is it starts with discovery. What do I have? And what's even interesting now is that there's this term that's, I don't know, I hear it everywhere I go, AI ready. This is the battle cry for the CIO. You must be AI ready. Like, if you're not ready to do anything else, be ready to be ready. So, so what does that mean? It would just mean like, okay, how do I know what I've got? And it's hard enough just to enumerate what devices do we have that hold storage. Like there's a whole cottage industry of vendors that'll go and inventory all your buckets on AWS and all your buckets on Azure and all your buckets on GCP and tell you all your buckets. Right, but then what about all your file systems and all your and all the file sets within the file? There's stuff everywhere. So even if you enumerated all that stuff, well, then you got to ask the question: all right, what's the data inside of these containers? And then you don't have a way to get to that, right? You as I mentioned, you need the root privileges in the first place to get there. So the person who's the data scientist doesn't have the means to get to this data. I mean, I'm sure you've seen this, but even in IT operations, we're taking away root privileges. We don't want to allow an individual to be able to log in, have keys to the entire kingdom, and forget to log out and then get taken over. Mm-hmm. So without these superpowers, you can't mine the data in unstructured data systems, right? And that's really fundamentally the bridge I'm gapping. Is I'm making that stuff accessible for management purposes. And the first thing you'd want to do is, all right, tally it up. How much of this do I have? How much of that? You start with boring stuff like file types and ownership, because those are easy to query for. Then you might go, all right, I need a deeper analysis. I need to open these files and get some content out of them. Or I need to ask users questions about how these things are organized. Or maybe I can deduce the organization from path names and then create some other analysis of what the data is. But none of that's possible without Starfish-like capabilities just to get access to the file systems and enumerate them.
I believe that we're in a fundamental shift right now of organizations, because they want to be AI ready, perhaps, or something along those lines, are much more concerned with this and putting attention to it, that instead of saying, okay, it's good enough that I've figured out to store how to store my data in the appropriate performance and cost tier, I need to now figure out how I'm actually going to find and use that data. And there's a forcing function that for both of our technologies and just in general, that
Oh,
organizations are
yeah.
now starting to actually
So
care at the C level.
So I kind of think of I think of my constituency, the users or the stakeholders in Starfish as really being three types, and I could subdivide them way greater than that. But if I go for the three, I have people who do storage administration, like they care about the devices. And then I have people who actually create and consume the data. Like they care about the data, and they shouldn't have to. In a perfect world, they don't care about the device, right? That should be incidental to them. And then there's this sort of third class of constituents who maybe we call them governance, stewardship, curation. There are people who neither care about the individual files nor the devices. They care about the practices, and they care about the value that's contained in that data. Right, so the file itself doesn't matter, but the data in the file probably does. And then all the housekeeping and governance, like protecting the patent portfolio, or dealing with compliance. Now, you could break that third group into probably 4 or 5 different groups, but I'll keep it simple and just say there's these three kinds of constituents. So they all generally work against each other in most organizations, right? Like the storage administrator is like, all right, I filled up my storage device. I got to delete some of this junk, or I got to move it somewhere else. But the users freak out. You can't just rip my
Yep.
data out and move it. So, okay, what do we got to do? We just got to go buy more. Like that's what typically happens, right? And then you might have like, okay, we've agreed. The users say we can move this data, and the storage administrators are ready to hit the big red button. But then the governance people come in and they go, oh, wait, you can't move that data to public cloud. It might have sensitive content in it. We need to know first before we let you do that. So these are the kinds of problems that I love. Like these are whenever we hit a friction point, then we go, okay, well, how do we fix it? And you go, all right, well, I got to look at the files that you want to move. I have to analyze their contents. I have to make a determination. And that's all a Starfish problem. Like I would say, give me a list of the files that you're interested in moving, because we identified those already. What's the risk factor? What's in the content? Well, let's open them up and look. And then let's record what we found back into the catalog so that we can, affect the actual batch operation that's going to move the files. Like that'd be the kind of problem that I love. But it's cross-departmental, and it becomes a people problem more than a technology problem. So I was surprised. I built these tools and I show them to my customers, and 1 out of 10 is like, let's do it. The other ones are like, let's convene a committee and come back in a year and then maybe do it.
Yeah, it's interesting to think about the different audiences and what they care about. And it kind of goes back to what people really want that you talked about at the beginning. They want to do all this and automate it and make it as easy as possible. And in some ways, there's Hammerspace solutions to automate. You can set an objective that says certain data types can't go out of geography, or certain data types can't be moved, certain data types need protection, but it's not granular at the level you're talking about, where you've actually had a file by file inspection of what you're going to do. And what I like about the combined technologies is there's safeguards that you can automate within Hammerspace, and then there's actual like human invocable things you can do through Starfish based on what they learn. And these are big things, like governance was a bad word. Nobody wanted to talk about it 10 years ago. It's kind of like this thing that's not the job you wanted to do in a company. And now it's become a hot topic again. And we have these tools for the people trying to solve these problems.
Yeah, I mean, what's interesting too is the integrations between like a Starfish and a Hammerspace are pretty darn trivial. Like, you guys have a notion of a policy or a metadata that triggers a policy. So you would be able to say, okay, these files they go to Deep Glacier, and these files get stored on the local Flash tier, right? But your ability to analyze that at a really you don't have the granularity to go down to what's in the actual content, or
Exactly.
or where does it fit in a workflow, like in a bigger context. But I have that. It's easy. And then because the concept again in Starfish is I query the catalog and all of its glorious metadata for the files I'm interested in, and then I do something with that result set. And often that something is simple. Like, I mean, I mentioned delete is the that's my killer use case. Um, Archive, make a copy somewhere and record that you made the copy. That's another easy one. But like setting a property in Hammerspace is even easier, right? I can flip a bit, through an API call to Hammerspace, and I can be the policy engine that gives you all this extra granularity that your product doesn't have. And then you can go and take care of your magic, putting the file in the right place and making that seamless to your user.
So we've talked a fair bit about the storage needs, kind of how our technologies are helping organizations. Let's dig a little bit deeper into metadata. It's kind of its own beast in some ways, and we've touched on it in a variety of ways. But when we talk about metadata, maybe if you can just give a high-level example of what is the metadata that Starfish retains, who has access to it? Is it humans? Is it applications?
Yeah, sure. So I think when you say metadata to a storage administrator, they're thinking about the files and directories on their file system, or the listing of the objects in their buckets. And they're usually, like, the concern that they would have with them is usually that there's just an awful lot of it and it causes systems to break. So if you have, a million files, you can run a find statement on a fast file system and get a result back in a minute, 2 minutes, whatever, and have your answer and you're happy. If you have 10 million, it takes a little longer. If you have a billion, it might take a month. So you there's that sort of the analogy to Heisenberg's uncertainty principle. By the time you look, it's too late. It's already gone. But that happens in file storage, is it's already gone. We also see problems in file storage as things that just break. Backup systems could break if you put too much metadata in them. They just don't work anymore. And file systems can just run out of metadata space or run out of inode headroom and just break. So just like dealing with the sheer number of files is a problem. So one of the things that Starfish is just great at is enumerating those files in a SQL database. And without, by the way, tons and tons and tons of hardware or complexity. It's just, we get that data in and it's then very visible and analyzable. But that's sort of step one for our metadata. The next thing that we store is the history of that over time. So we're constantly scanning and rescanning your file systems. Depending on what kind of file system you have, we have different tricks that make it super fast or not so fast. In some cases, like, in one of the world's largest supercomputers at one of the national laboratories, we're able to sync their file systems like on I think it's like a 1 or 2 minute interval. Like, they're always really, really fresh. More common might be to be once or twice a day. That might be a bad result, but whatever. We're keeping the history over time. So if you move a file or delete a file, I still remember it. That's another critical piece of our metadata. And we use that, by the way. That's critical for backup and restore workflows. You can query for versions or points in time. It's wonderful for doing API-based archive and recovery. Like, I don't need symlinks or stubs in order to put files back exactly where I found them. It's wonderful for data migrations. Whenever we migrate data, we usually do it in stages where there's a big migration first and then a series of incrementals and then a final sync and true up. It's wonderful for just measuring the file environment, what turned over, what churned. That data is really useful for any kind of sizing exercises, super useful for chargeback and accounting purposes. So that's the history metadata. Then we've got tagging. And in our system, a tag is just a simple arbitrary label that you put on a file or a directory, but there's some neat twists to it. So we're able to, if we tag a directory, we can query for inheritance. So I could either say, get me every directory with, the archive tag on it, or I could say, get me every subdirectory underneath the directory with archive tag, or get me every subdirectory and every file underneath a directory with archive tag. And I can use combinations of inheritance and explicitness and file-based tagging and directory tagging to be very specific about what I want across the whole storage environment. And then lastly, we've got key value metadata. So in our two major components, the data catalog and we have this sort of data mover and batch processor. The way the data mover batch processor works is it queries the catalog for the stuff you want to move or process, and then it goes and does it. And it does it fast and furiously across multiple servers and multiple threads. But as it's doing its magic, it has the option to update the database. And the way it does that is it simply formats JSON. It's a document of key value pairs, and it puts that into the database, and then those key value pairs become discoverable, actionable, reportable properties of the files and directories. So in other words, whatever we do to a file or whatever we discover about a file goes back into the metadata. Now, most of this, by the way, is like information that's really useful for managing and finding and like interacting with your files. There could still be much more interesting metadata that's outside of our scope that some other system might retain. Like in science, there's lab notebooks. In medicine, there's PACS systems. And media entertainment, there's digital asset management systems. And legal, there's document and case management systems. But all those external metadata systems could still reference the data in Starfish. Like another common trick we do is again, it's so simple, but it's so obvious, is we can calculate a hash or a checksum on a given file and use that as a content address for an external metadata system. So if there's more metadata you want to store about a file than what naturally fits inside of Starfish, have us calculate a hash, use the hash to associate the file with some other body of metadata, and off you go.
It would be good to dig a little deeper into, maybe we talk about the media and entertainment workflow where there is an asset manager in place. Maybe they're using Starfish for the metadata, and then they have a file system, whether it's Hammerspace or StoreNext or NetApp, whatever it is, underneath it. Who should own the metadata, and what is the metadata flow?
Oh, well, yeah. So media entertainment's been an interesting market for me because it's one of the few industries where the techie people, the operations people, understand metadata. Like it means something to them.
Deeply,
and sometimes because it means something so specific, it's hard for them to imagine where they're going to use Starfish. So the first thing that I could do in like a big post-production house, for instance, I think is to say, all right, out of all these files that you own, the ones that really matter for the most part, are underneath the media asset management system. And you know what they are and you know where they are. And by now, you hopefully have reasonable tools to move them around. But what about all the files that aren't in the media asset management system? What about files that were checked out and they're lying around on a disk somewhere and maybe they're out of license and they're supposed to be deleted, but you've forgotten because they're not underneath the umbrella anymore? Or what about derivative works that haven't been checked back in? So it might be interesting to have like a holistic inventory of all of the files and then compare those that are in the MAM system to the ones that aren't in the MAM system. And then maybe there's some logical workflows to clean that up or remediate a situation. Like that might be a use case for Starfish. Or believe it or not, another common use case for us in a media asset management is as a backup system. And if you think about conventional enterprise backup is based on the idea that the most important data is the data that was changed yesterday. We're always worrying about getting granular incremental backups, and eventually we no longer want to retain all the versioning and all the history. But in a digital asset management system, those are all digital assets. And what you really want to make sure is that you have legit integral like copies of everything and multiple copies of them. So a really funky use case we did at Starfish was we did the back end of the digital asset management system at Harvard University. So Harvard has an internal DAM system that they built over, I don't know, like 1,000 years.
Forever,
like
yes.
They started in 1660 building a DAM system before that was even a concept. And they have an incredibly sophisticated system. It's got all the digital assets from their museums and their libraries and the minutes of the Harvard Corporation. It's tons of stuff in there. Each of those collections has different storage management rules. Like some get copied here, here, and here, and some get copied there, and there. 3 copies, 4 copies, 5 copies, this secure location, not in that location. And basically, we do a simple handshake of metadata between the DAM system and Starfish so that we understand how files relate to collections, and then we store the data appropriately based on the collection. And that's an easy integration to do in Starfish. It would have been, you imagine what a pain in the butt it would have been for them to build that kind of functionality into the MAM system. But thinking of Starfish as a middleware that enables all that kind of stuff outside of it was quite simple. So those are the kinds of things like I would be like all of these other metadata-driven use cases that are different from what the MAM system does.
Yeah, that makes sense. And you touched on something I'd mentioned related to the Hammerspace technology and those workflows. One of the things that's cool about what Hammerspace will do is we'll put a single file system which everyone's interacting with over the devices, whether it's storage and users. So that idea of copies getting outside the system, of copies being taken external from where the metadata is being updated, it is no longer a problem. Everybody works within a single global file system, and that's one of the things that's really interesting. Is there's the namespace of seeing everything, but then there's actively everybody's working on the same version of data instead of having to make copies. So we have a layer below that that simplifies, let's just not make copies. And then what updates are being made are being done in metadata, whether it's in Starfish or MAM or wherever it sits. It helps to simplify some of these potential problems that proliferate in user behavior.
Yeah, I mean, anytime, there's some other nastiness about hierarchical file systems or POSIX file systems, which are funky things like, when you rename a file, you moved it. And when you move it, you renamed it, right? There's this weird relationship between the location of a file, its addressable location, and the label of what you call it. And what that means also is that if somebody renames a directory, they just renamed all the content downstream from that directory. So anytime a file leaves a namespace, you're asking for it. And I think the magic of what Hammerspace did is you've got this namespace trick. You're able to federate a bunch of disparate storage devices into a common namespace, or you're able to replicate that namespace with a really unusual consistency model so that you can access it from multiple geographies without really confusing what its contents are. Like those, I think, are your magic tricks.
Yeah.
And when I think about namespace operations, I'm thinking, well, if there are multiple namespaces, even after you're done, even after Hammerspace has rolled a whole bunch of them into one, there might be another or another or another. Or the namespace might not be the POSIX namespace. It might be the collection as defined in your media asset management system. So if the media asset management system is supposed to be the single source of truth, then presumably all the files in the file system are being tracked by the media asset management system. But we find that in most organizations that have really comprehensive metadata-driven solutions, there's always tons and tons of files that aren't underneath that umbrella. In that sense, there becomes multiple namespaces and things are no longer managed.
Yeah, I agree with you. So I think one other piece as we think about metadata, who should have access to it? Is it any application should be able to read and update it? Any user? Is it something that needs to be controlled in these governance environments?
Well, it really depends on what the metadata is. So in a media asset management system or a PAC system or the document management system in a law firm, the roles around metadata are usually really carefully governed. Like that's the core IP of those products. When you get into file storage, and what you and I do, like we're presenting files to users who need to read and write and create and collaborate. And they're very deliberately choosing not to work in a structured portal environment. Like they need to read and write to file systems. So we struggle with this. We struggle with, do I respect file permissions? Like, do you have to be a file owner to put metadata on it? And we decided, no, you don't. Like we find in most of our use cases, like let's take a science use case. You've got a laboratory, a bunch of scientists. There might be someone in the lab whose job it is to, understand their data and how it gets orchestrated. But that person might not actually read and write the data. They have no business opening the files. They just need to direct how they're managed. So we created a model whereby we can kind of logically break up the file system into these discrete chunks. And the chunks can be from anywhere in the storage environment. We call these storage zones. So I would just say, all right, hey, Molly, here's like 10 directories from around the storage environment. This is your stuff. And then I assign you as a user and maybe some other people that work with you, and you guys can all do metadata operations on this space within all of our global storage. Now, that's how we did it. And we found that that's a good approximation for the kinds of things we do. But then we've already been running into the need for more granular controls over that. So for instance, here's a common problem we have is that if you wanted to make a tag in Starfish, you're a user, we don't let you make a tag. You got to go to the storage administrator. But what if you're a librarian and you're trying to make a scientific ontology using the tagging system? It just feels funny to call the storage administrator and say, could you put some of these tags in there for me? Like, it makes more sense to be like, all right, this kind of metadata belongs to the librarian and they're going to decide what the tags are. And maybe these people are qualified to apply these tags and other people are qualified to apply other tags. Now, as it turns out, most of my customers are doing storage operations. I told you my top use cases are rot cleanup, archive, delete. So we're not using incredibly rich metadata that requires library style, like ontological science to do it. It's kind of like good data, bad data, delete me, don't delete me. It's like stuff like that.
So, Jacob, I think that as customers listen to this podcast, and I think a lot will, as they're looking to grapple with the types of problems that we solve, what would you leave them with as far as working with our two companies, assessing their architectures? I mean, you've been in an advisory role forever. What are the first steps on, okay, I know I need to do something more modern. It's a bit confusing. This podcast helps distill some of the questions to look at and think about. But what are the first steps that they need to take if they want to get a better handle?
All right. Well, I think both your product and my product have broken down barriers that people take for granted. So most of my clients have long since given up on knowing what the heck they had in their file systems and being able to do anything with it. They were just like, it's just too big, we give up. And we've given them the power to dream again. We're able to say, okay, now that you can understand what's in there and you can make it do what you want, what problems do you want to solve? And I think you've done the same thing. Like, you've just said, hey, what if these 3 file systems from 3 different vendors behaved like one? What would that change for you? And you said, hey, what if these 10 different branch offices, all could interact with the same common namespace without getting confused about stuff? Then what? So these are age-old storage problems. And I think just the fact that they've been solved now means that people are free to imagine again. So, it goes back to, I ask the clients all the time, what problem are you trying to solve and what do you imagine the solution looks like? And then we reason it out and we deploy the appropriate pieces.
I think that's a great way to leave and tie up this episode, at least, Jacob. Lots of food for thought. What's the best way to get in contact with you, your companies, if people want to further discuss some of these topics?
Yeah, we're at starfishstorage.com. I'll mention that it takes us about an hour to walk a customer through kind of what we do and how we do it. Almost everybody leaves saying, oh my God, I have too many ideas. I need to take a nap. And then we're super generous with proofs of concept. I really like to de-risk the sale. People should know what they're getting and how they're going to get their ROI before they buy it. I don't know, we're easy to work with.
Awesome. Thank you for taking the time to talk with us today. Really interesting conversation that dug into some really great topics. I appreciate your time.
Yeah, well, thanks for having me.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.